Hello and welcome to another video where I go through our homework. Okay, so let's get on with it. Let me just move the microphone so it's not really far away, so hopefully you can hear me. Okay, lots of this homework you can get by on Pascal's. But can I, before I start, just highlight when the questions get difficult? They get difficult when the power is unknown, like in question 6 and question 7. That's when they get difficult. Now, most of the time you can get through on knowing Pascal's triangle. And I'm sure I don't need to lecture you on that. That's something which you do straight away. Sorry about how wonky my triangle is here. If you know it down to, well, you don't have to know it, obviously, because you just add the two numbers above to get that number. That's how I'm getting 15 here, 20 here, 15 here, 6 here, and 1 here. The entire triangle generates itself. But it's really important as well to know that n choose r is coding for this triangle, particularly when you get down to these questions. And in fact, now what do I mean by n choose r is coding? Well, firstly, here's a formula for n choose r. It's m factorial over r factorial m minus r factorial. Yeah. And let me show you that it does work. Remember that you start on 0th row and 0th element in the row. So, you know, for example, this is n is 0, n is 1, n is 2. It's like a coordinate system in a triangle, really. But this would be r equals 0, r equals 1, r equals 2. Yeah. So if you wanted to, for example, know what n choose 3 is, and it should come out as 20, sorry, 6 choose 3 is, and it should come out as 20. Let's just see the formula working. That's apparently the same as 6 factorial times 3 factorial times by 6 minus 3, which is another 3 factorial. And that's going to give you, now we don't have to write it all out because the 3 times 2 times 1 is going to cancel with one of these. So you're just going to be left with the other 3 times 2 times 1. But that cancels with the 6. So you're left with 20. Yeah, see what I mean? It genuinely works, the coding for Pascal's triangle. Now, why am I waffling on about this before I've even started? Because I just want you to understand that n choose 0 is always 1 because you're just taking the 0th element from that diagonal. And you can plug it into the formula and you'll see it works. It's because it's n factorial over 0 factorial, which remember 0 factorial is 1. And then you've got, you know, n minus 0, which is n factorial. So you've got n factorial over n factorial, which gives you 1. N choose 1 will give you n, and that's because you just get the natural numbers down that diagonal. So you're going to get m factorial over 1 factorial, n minus 1 factorial. Now, why does this end up being n? Well, because it's n times n minus 1 times n minus 2 dot, dot, dot. But m minus 1 factorial is just m minus 1 times m minus 2 dot, dot, dot. So all of those cancel, leaving just n. Now you can make similar arguments for n choose 2, where you're going to get n times m minus 1 over 2, because, well, let me actually show you it working out. You can normally see the pattern after a while. You get m factorial, 2 factorial, m minus 2 factorial. It's a bit unclear what I'm doing on the graph here. I know you're probably thinking, why is he not even going through the questions? I want to show you this. This is particularly if you're stuck on 6 and 7. Watch this bit of the video if you're stuck on 6 and 7. Now, m factorial is n times m minus 1 times m minus 2 times m minus 3 dot, dot, dot. And then you've got 2 factorial, which is just 2, but then you've got times m minus 2 times m minus 3 dot, dot, dot. So they just cancel. And you get rid of all your factorials again, leaving n times m minus 1 over 2. Really handy to know this. Honestly, you're going to thank me for this at the end. N choose 3, where you're going to have m factorial over 3 factorial, m minus 3 factorial. Well, that comes to n times m minus 1 times m minus 2. I'll write out the next one times m minus 3, and I'll just put dot, 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 because you get the pattern. Now, 3 factorial is 6. And then you've got times m minus 3, dot, dot, dot. And so they all cancel, leaving n, m minus 1, m minus 2 over 6, which is 3 factorial, by the way. I hope you can guess what n choose 4 is going to be, because you can see we're building up a pattern here. n, n minus 1, n minus 1, n minus 2. The next one's going to be n, m minus 1, n minus 2, n minus 3 on the top. But rather than being over 3 factorial, we're going to be over 4 factorial this time, which is actually the same as 24. Yeah, I'm going to use all those ideas later on. That's what I wanted to say before we start, because you're probably stuck on 6 and 7. I totally get that. It's all about that. If you just memorize those results, or just quietly see why the formula deduces that, it's really important to see that that formula works and always ends up giving you that. You can always give n choose a number in terms of n without any factorials. And you want to be able to do that. Okay, let's get started then. Right, write out this expansion. Well, I normally encourage one line for writing down stuff. So we've got 3 to the power of 4. I normally write down with a big gap, a 3 cubed, a big gap, a 3 squared, a big gap, a 3 to the power of 1. It's annoying that there. Yeah, get rid of it. And then a 3 to the power of 0. And then next to it, I normally put a minus 2x to the 0, a minus 2x to the power of 1, a minus 2x to the power of 2, a minus 2x to the power of 3. So these powers climb while the other power goes down, and a minus 2x to the power of 4. Let's just budge up a bit. These questions, take a lot of algebra. And then I put my n choose r's in, normally before the terms as well. So I'm going to have a fair bit of space here. This is essentially now, because we're doing it to the power of 4, we want the fourth row, 1, 4, 6, 4, 1. So now you can plug in your Pascal's coefficients. 1, 4, 6, 4, 1. Yeah. Now, what's that going to give us? You can tidy it all up now. 1 times 3 to the 4 times anything to the power of 0 is 1. So that's going to be 81. This is going to be 27 times 4, which is 108, times by 2 is 216. And the signs are going to alternate here, because this is going to be negative, the next one's going to be positive, etc., etc. You're going to get 4 times 9, which is 36. 36 times 6 is 216, x squared. And then you're going to get 12 times by 8, well, that's minus 96, x cubed. And then finally, this one's going to be positive, and it's going to be 2 to the power of 4, so that's 16x to the power of 4. And that is it. You probably got this one right, though, so you probably fast-forwarded past this, but fair enough. Okay, next one, similar thing, but a bit more difficult. We're only doing up to x cubed here, yeah? And we want x to the power of 8. We could do that with Pascal's. We could do it with a thingamabob. Now, you're going to have, for the next row, 1, 7, 21, 35, 35, 21, 7, 1. And for the next row, 1, 8. And I just need the first few, 28, and then 56. I think that's all I'll need, because I'm only going up to x cubed. So I just need the first 4 terms. Okay, so what are we going to have? They should really say in ascending powers of x here, and it's kind of implied because it's going up to x cubed, but we want the powers of x to go up. Okay, you're going to have 1, and if you like, I don't bother writing this down anymore. I did in the last question, but put this to the power of 0, and put that one, the 1 to the power of 8. But, both that and that do nothing at all. That term's going to end up being 1. And then you're going to have 8 times by minus 3x over 4 to the power of 1, if you like. And then you're going to have 1 to the power of 7. The powers always add to give that. Then you're going to have, what was the next number? I've already forgotten it. Was it 28? 28. 28. And you're going to be doing minus 3x over 4 squared times by 1 to the power of 6. I'm sure you probably didn't write down the ones. I don't blame you. And then lastly, plus 56 minus 3x over 4 cubed. Do use a calculator on these. Times by 1 to the power of 5. Okay, one line writing down it all like kind of messy, and then one line working it all out. Okay, 3/4 of 8 is 6, so that's going to be minus 6x. I just put a plus there. Okay, 3/4 squared is 9 over 16. 9 over 16 times 28 is actually going to give you 63 over 4 x squared. Feel free to use a calculator there, obviously. And the minus becomes plus because of the squared. And then lastly, the next term, once you've worked it all out, I think it's going to be 189 over 8x cubed. I believe. Right, let me just check that in my calculator because I could easily mess something this up. Type it in carefully, you know, do the 3/4 to the power of 3, then times it by 56. That's how I do it anyway. And you get 189/8. We're good. Okay, so I hope that one's fine. Okay, the question about Mr. Caulfield playing chess. Now, I can tell you that he used to work here and he was actually an international master, so he probably had a slightly higher probability of winning than that, to be fair to him. So there we go. But he's taken on all 9 members of the department, and apparently some of us are beating him. Good. Find the probability that he wins exactly 5 games. Okay, so he's playing 9 games. So let's actually define this as a binomial distribution where he's playing 9 games and his probability of success is 0.85. If he wins exactly 5 games, we're looking for the probability that x equals 5. Now, your calculator will work this out, but just to show you the old way of doing it, we would have done 9 choose 5 multiplied by, well, we need to do 0.85 5 times because we need him to win 5, but then we need him to lose 4. And so we're going to do that. And that comes to, okay, so I'm going to actually do this the old way. Just typing it into my calculator, I get 0.028. So it's quite unlikely that he only wins 5 games, actually. He wins at least 1 game. This is a bit of a silly question, really. It should have probably been something like wins at least 6 games or something like that. Because the problem with the probability that he wins at least 1 game is it's going to be extremely high because it's the opposite of him losing every game. So find 1 minus the probability he loses every game. That's like a really snazzy way of doing it. So that's 1 minus, and losing every game will be 0.15 to the 9. And so you end up with a really high number, like basically 1. Of course, he's going to win a game. Minus 0.15 to the 9. Okay, I'm getting like 0.9 recurring. So if you've got 0.99999999, of course he's winning a game. He's an international master. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then it was like that on my calculator. It's a bit of a silly question, though, such a silly answer. Okay, more than 7 games. Well, you need to work out the probability that he's going to win 8 games, and work out the probability he's going to win 9 games. And then that's the probability that you win 7 games. Now, the long way of doing that, the old way of doing it, which isn't the super duper way of doing it on your calculator. Fair enough if you did it on your calculator, I don't blame you. We'd need to do that. But then we'd also need to do 0.85 to the 9, add them together, and you get 0.6 roughly. So there we go. A bit of a funny, silly question. And that's showing you binomial probability in statistics, actually. It's giving you a little window into what binomial probability is like in statistics. Okay, for A, write out the expansion. Right, so let's just do this underneath here. We're going to have 1 times by 2x to the power of 0 times by 1 to the power of 11. But I'm just going to write that as 1 straight away. I hope you don't mind. Then we're going to have now we're doing it to the power of 11. So we're going to have 11 times, that's Pascal's coefficient. That's essentially the 11th of Pascal's triangle. Then we're going to have 2x to the power of 1 and 1 to the power of 1. And we're only going up to x cubed here. Now the next term is going to be, that's 11 choose 0. That's 11 choose 1. If you now press 11 choose 2 on your calculator, it's normally above the division button, you get 55 times by 2x all squared. And then if you press 11 choose 3 on your calculator, so you do want to know the n choose r stuff, you get 165 times by 2x. My x is getting really dodgy here, cubed. Anyway, let's simplify that. I'm just trying to save space here, really. 1 plus 22x plus, okay, 55 times 4, so that's 220x squared. And then 165 times 8, that's 1320 x cubed, yeah? But learn n choose r. It's a really important technique in this. Okay, hence find the approximation to that. Well, we're basically saying here that x is 0.002. And I can see that because we've got 1 plus 2x. So if I had x is 0.002 and I doubled it, I'd have 0.004 and I'd get the rough answer to this. Plug it in and we get it roughly equals 1.045. And what I've done is I've plugged x is 0.02 in here, and in here, and just done that on my calculator. Okay, right, the series expansion up until x cubed. Here's what you've just got to do. 3 minus x times 1 plus 2x to the power of 11, which was, obviously, let's just rub this out straight away and change that into, we've already got an approximation for this. It's 1 plus 22x plus 220x squared plus 1320x cubed. And now you just have to basically multiply this out, but ignore higher powers higher than x cubed. So we're going to get all of it times by 3. So I'm going to get 3 plus 66x plus 660x squared plus, now what is 3 times that? 3960 x cubed. And now I need to times it all by minus x. So I'm going to get minus x minus 22x squared minus 220x cubed. But the last one I'm not going to do. Why? Because minus x times 1320x cubed is x to the power of 4, and all I need it up to is x cubed. And so that's going to give me 3 plus 65x plus 638x squared plus 3740x cubed. And those questions are quite common in the exam. You've just got to multiply it out. Bit tedious, but quite common. Okay, number 5. We're expanding 2 minus px to the power of 6 in ascending powers of x as far as the term x squared. Okay, so let's do it. We get if we were going to do the expansion, ignoring their answer for the moment, I would have 2 to the power of 6 for my first term, times by 1, times by minus px to the power of 0. But as you can see, I've stopped writing that down now. I wrote it down in questions 1 and 2 just to show you the pattern, but I know the other two are going to come to 1. And then I'm going to have 2 to the power of 5 times by my minus px to the power of 1, and then also times by 6, because we're to the power of 6 in this, so this is going to be 1, 6, 15, and so on and so forth. And then my next one's going to be 15 times by 2 to the power of 4 times by minus px all squared. And that's because I'm dealing with the sixth Pascal's triangle. I know a lot of people love Pascal's triangle. There it is, 1, 6, 15. And I only need to go to x squared because that's all they've done. So let's simplify this. This gives me the 64, which agrees with their answer. This gives me 32 times 6, and 32 times 6, I'm just working that out, a bit cowardly that, minus 192 px. And then I'm going to get 15 times 16, which is 240, p squared x squared. Don't forget to square the p. That's where my students normally go wrong. And then we can equate coefficients because they've told us that the answer is supposed to be like this. And so what I can do is I can link this value with this value, yeah? So I can see that 135 is going to be equal to 240 p squared. And so that gives me p squared is 135 over 240, square root it, you get p is 3/4. Okay, we've got p. We can now find a because minus 192 times by p, which is 3/4, equals a. And so we need to find 3/4 of negative 192, and that gives us a is minus 144. And there we go. That's it. Okay, right. I'm just going to have a quick coffee break before I do this. I'm going to pause the recording and come back to it. 1 second. Okay, that was a 2-hour-long break for me because I had to teach a lesson, but hopefully it was barely a second for you. Okay, so we're doing question 6. The first 3 terms in the expansion in ascending powers of x are for 1 plus px to the n, are 1 minus 18x plus 36p squared x squared. Now, I always say to my students, if you've ever got to find the power, that's when you tend to need this thing I showed you at the start. N choose 0 is 1, n choose 1 is n choose 2 is n times n minus 1 over 2, n choose 3 is n times n minus 1 times n minus 2 over 6. But you might prefer to look at that as 3 factorial, because that's 3 factorial. That's really 2 factorial. It's just what it simplifies to. That's really 4 factorial, which equals 24. Just to see that we've got the pattern, n choose 5. You guessed it, n minus 1, n minus 2, n minus 3, n minus 4 over 5 factorial. Yeah, I'm just trying to show you what the pattern is here. Now, we're not going to go this far probably. Maybe in the last question, I can't remember. By the way, I think that's 120. But yeah, that is what you want to know for these ones where you have to find a power n. So make sure you're aware of how I've derived that. Look right back at the start of the video because I go through how I derived that there. So that's the ideas I'm going to use in number 6 and number 7. Okay, so 1 plus px to the n. Let's actually try and expand it because we know what it expands to give. So I'm going to try and expand it. If I was expanding 1 plus px to the n and I was only interested in the first 3 terms, then what I'm going to have first is n choose 0 times by 1 to the power of n times by px to the power of 0. Now, I know this is going to give me 1, but I like to write it down so students can see the pattern sometimes. I don't always write it down. Sometimes I do, sometimes I don't. Next, we're going to have n choose 1 multiplied by 1 to the n minus 1 multiplied by px to the power of 1. And next, we're going to have n choose 2 multiplied by 1 to the n minus 2 multiplied by px all squared. Cool. Dot, dot, dot. I only need the first 3 terms, so that's fine. Now, n choose 0 is 1. 1 to the power of anything is 1. And px to the power of 0 is 1. So that's 1. That hasn't really told us much because we already knew. It's reassuring, I suppose, because they also start with a 1. That's what we're starting with. Then we're going to have n choose 1. And n choose 1 equals n. Yeah? And that's because n choose 1 is n factorial over 1 factorial times n minus 1 factorial. But n factorial is n times n minus 1 times n minus 2, going on until you get to 1. And n minus 1 factorial is n minus 1 times n minus 2, going on until we get to 1. So that cancels with that, just leaving n over 1, which is just n. So what I can do here is write down, this is the same as n times by 1 times by p times by x, npx. And then here, this is going to be n times n minus 1 over 2, because that's what n choose 2 equals. See? And it's because the n factorial cancels with the n minus 2 factorial, leaving just n minus 1. And then you're over 2 factorial, which is 2. Then we're going to times by 1, and then we're going to times by p squared x squared. Now remember, they told us the answer should be 1 minus 18x plus 36p squared x squared. Let's write that down. And now we can use the trick, which is called equating coefficients, because these are supposed to be exactly the same expressions. So I can now derive that np is minus 18. And that's by looking at the x terms. So I'm just looking at the coefficient of x there. But I can do the same thing with the coefficient of x squared and say that 36p squared, well, that must equals all of this. If I can dot it. So n minus 1 p squared over 2 equals 36 p squared. I've not bothered with the x squared because they've both got x squareds on there. Oh, that one has now. Both got x squareds on there. So they're both, you know, we're just looking at the coefficient of x squared. Now, what I can also do is cross out the p squareds because I'm essentially dividing by p squared there. So what have I got here? I've got n times n minus 1 is 72. I can multiply that out as a quadratic. N squared minus n equals 72. So n squared minus n minus 72 equals 0. Factorize the quadratic. Two numbers that add to give minus 1 times to give 72. What is that? 9 and 8. N minus 9, n plus 8. And so n equals 9. I ignore the minus 8 solution because n is a natural number. It told me it, oh, a positive integer, and that is not a positive integer. So n equals 9, and therefore, once I plug n equals 9 into here, I get p equals minus 2. And the whole question is done. But it's absolutely crucial that you know what n choose 0, n choose 1, n choose 2 are. This question is no different. I'm going to need to know, and so I'm going to write them down here. N choose 0 is 1, n choose 1 is n choose 2 is n times n minus 1 over 2. Absolutely critical for these kinds of questions. N choose 3 I'll put down, because I think this one, if memory serves, this one goes quite far. Over 3 factorial, which is 6. Okay, right. We're told that the coefficient of x cubed is twice the coefficient of x squared. So I will need to go up to here actually first. And so let's do part A. If I was to do the first few terms up to x cubed, I would have f of x equals 1 to the power of n. Well, if you like, n choose 0. Let me write it all down so you see the pattern. N choose 0 times 1 to the power of n times by x over k to the power of 0. That's going to end up equaling 1 though. Then n choose 1 times by 1 to the n minus 1, that's just 1, times by x over k to the power of 1, plus n choose 2 times by 1 to the power of n minus 2, times by x over k squared, plus n choose 3 times by 1 to the n minus 3, times by x over k cubed. Now, sure, if some people are thinking, oh, I only needed to do this term and the preceding term, these two terms, I completely agree. I just like to show people the pattern so they get used to the pattern. Now, what do we know? The coefficient of x cubed is double the coefficient of x squared. So I'm going to look at x squared. I'm going to see x squared is n times n minus 1 over 2. That's the n choose 2 bit. Times by 1. We can safely ignore that. Times by x squared over k squared. Yeah? Now I'm just going to write these down so it's nice and clear. This one's n minus 1, n minus 2 over 6, because that's 3 factorial, times by 1, times by x cubed over k cubed. Now, it's only the coefficients of x squared and x cubed that I'm interested in. And so what I'm going to do is just take the coefficient of x squared, which is n minus 1 over 2k squared. I've ignored the actual x squared because it's only the coefficient I'm interested in. Now, I can't remember which one I've got to double. Let's have a look. X cubed is double the coefficient of x squared. So I need to double the coefficient of x squared, which is the one I just wrote down. And that should equal the coefficient of x cubed. Okay. Now that may look really, really ugly, but tons of stuff is going to cancel. If you times, both sides by k squared, well, firstly, 2's cancel there, yeah? Secondly, both sides have an n times n minus 1 on them, so you can actually cancel those out. And then if I just time this 6k cubed over here, I'm going to have 6k cubed over k squared, which is just 6k, equals n minus 2. And so 6k plus 2 is n, which I hope is the answer. 6k plus 2 is n. Done. Okay. Part B, similar kind of aggravation, really, because we now have the coefficients of x to the 4 and x to the 5. Now, if you remember, I've actually done this up here. We've got x to the 4, well, n choose 4 there, and n choose 5 here. We're going to have to write all those out. The coefficients of x to the 4 and x to the 5 are equal. Now, look at what happened here. You're going to have an x to the 4 over k to the 4, and an x to the 5 over k to the 5. Yeah? So what we're going to have for x, I'll write it down underneath these terms. X to the 4, you're going to have n minus 1, n minus 2, n minus 3 over 4 factorial multiplied by x to the 4 over k to the 4. But for x to the 5, you're going to have an even longer expression, n minus 1, n minus 2, n minus 3, n minus 4, all over 5 factorial multiplied by x to the 5 over k to the 5. Brilliant. We can now ignore the x's because we're only interested in the coefficients. And as they're equal, we can equate them. Bit of a lengthy one, this one. An epic, as you might say. Oh, I've left the k off here. This is going to be 5 factorial times k to the 5. Okay, loads of stuff cancels. The n's, the n minus 1s, the n minus 2s, the n minus 3s cancel. Tons of stuff cancels. Times this over here. Now remember, if you've ever got 5 factorial over 4 factorial, it's just 5. Because you've got 5 times 4 times 3 times 2 times 1, which would be on the top. But then 4 times 2 times 3 times 1, which would be on the bottom. So this would be 5k to the 5 over k to the 4 equals n minus 4. And so you get 5k is n minus 4. Or if you prefer, writing in the format I had earlier, 5k plus 4 is n. Now, we've already got 6k plus 2 is n. So 6k plus 2 is 5k plus 4. Take away the k's, take away that, so it's going to give you k is 2. And if k is 2, n is 14, which is bound to be what we need to do. Find the values of k and n. Yeah. Form another equation, show that k is 2, n is 14. There we go, we did it. And using these values of k and n, expand it up to and including the term in x to the 5. Okay, right. Well, what a long question this was. We now just need to plug in these values up into this thing we wrote down here, which is nice. So f of x is going to equal 1, because that's 1, that's 1, that's 1. Right, we know what n is, it's 14, so that's going to be 14 times 1 times by x divided by 2, so that's 7x. Then we're going to have 14 times 13 over 2, because that's n choose 2, or if you just like, type into your calculator 14 choose 2. So you're going to do 14 choose 2 times by 1 times by x squared divided by 4. That actually gives you 91 over 4x squared. And I'm just plugging numbers in here. Similarly here, do 14 choose 3 times 1 times by x cubed over 8. And you're going to get 91x cubed over 2. So we're just plugging numbers into a calculator here. Similarly for the next one, but we need to actually, for the x to the 4 term, if you look here, we need to do all of that, plugging n in as 14 and k in as 2, and we get 1001 over 16, x to the power of 4. And lastly, in a similar way, 1001 x to the power of 5 over 16 as well, because these terms are supposed to be equal, and that one is supposed to be double that one. Yeah, so sure enough, we've got it. Cool. Okay, and that's that question. That is a really tough one, though, that one. That's very, very difficult. Well done if you got it right. All the best.